Sorry guys. Yeah, so just met a new friend and I just had to tell him. Let me tell the guys, this is live now. Everyone. Okay, cool. And we are live. Cool. So I'm hoping my video is working way better today. I hope it's not buffering as much as it was. I can see it says excellent conditions, so we do have a good connection today, hopefully. So yeah, the last time we streamed was a little difficult because we had internet trouble and we had PR trouble and things were not working out as much as we expected. So I think today what we're gonna do is kind of take a step back and try and establish what issue we're facing and see if we can actually attack that issue from some other angle, probably. So currently we have this board over here, which is the STM32. I think I actually don't need the UVC cable because we're not going to be doing UVC. As we've established, UVC makes my stream crash. So we're going to be working on the NUCLEO N6570Q or something like that. And what we want to do is we want to actually try and successfully interface it with the IMX219 camera. Both of these are like very partially covered in Zephyr right now, and actually they're not even in mainline. So we're actually working on pull requests, and we're trying to make sure things work before things get to main. Open source, you can just go do stuff. So what are we gonna do today? Hi Bartholomew, I see you. Thank you for showing up. What we're gonna do today is we want to actually just try and debug this application and see if we can find out why it's failing. The lucky part is the error that we are getting right now is an error we are actually experienced in. We just fixed this with the Freedom board on the Freedom NXP board. Where we had to make a patch so that the Freedom board could work with the OV5640, I think, camera. So this comes in with a little bit of experience. So first of all, before we come back to the notes, let me actually show you what is happening. So I have my code here. And this is the Zephyr project. So I'll just jump into Zephyr itself. Actually, this is bad. I don't like mixing things up like this. So I'll just add a new table here, add a new tab, and then I'll go into the Zephyr project. And what I'm going to do is git status. And in the git status here, you'll see the thing that I've modified is the capture project config and the samples. And if I do git diff, you'll see that just added stuff that we were using from git diff -- staged. So what I did was, why are you doing that? Oh yeah, oh okay, cool, because it's not a new file, it's not in the tree. So what I did was I copied cut samples, drivers, video capture app.overlay. So look at that. I just copied the overlay that we were using for UVC on this side. And all I did was I did not include the UVC header on the top. So that means this is not UVC, this is just capture. Okay, cool. So the camera should work and all of that. That's what I'm trying to show. Besides that, git diff. I did have to add these two configurations into the project config. That way we can have that way the RAM works just fine. That's basically it. That's really it. And then basically we have a working capture sample. So today we're working in Zephyr, samples, driver, video capture, just video capture. Because if we work on UVC, then it crashes our stream. And I don't want to do that today. That's a separate issue. We can fix that later. Let's actually try and fix video working on the Nucleo N6 today. Cool. So I've given sort of like basis of where we are today and what is happening. Okay, so the next thing we're gonna do is here where we've activated the environment, our virtual env. So let's actually just build for, although I have already, let's actually just build this project, build the samples, drivers video capture project, and see if we can actually flash it into this, just to make sure, just to start this stream from afresh. And anyways, if anyone has any question, this is a good time to ask because we're building and it takes time to build. Welcome anyone new and everyone new. In the description of the video, there's a link to our Discord community where you can join us and discuss all of these things and learn together and know when I'm posting and such and all of that stuff. So welcome, join us. Thank you so much. And if you have any questions, whenever you see this building, it's always a good time to ask questions because I can look at YouTube comments then. Cool. Any questions so far? It's just been 5 minutes into the stream. Any questions so far? None whatsoever. No questions. So probably too early to ask questions. Probably never too early to ask questions. Just ask any question you have. That's way better. And it also helps me because I think through the question that you've asked and I can see if I'm missing something. I'm not professing to be the person who knows everything about this. So that's really it. Let's see. Let's see what happens. So that's building. I expected that it will build successfully all the way, and that's okay. Cool, it builds. Okay, and then I'm gonna change my flash, my boot pin on the Nucleo because you have to change the boot pin and put it in boot mode. And then I'm gonna do West Flash. I'm gonna do West Flash, which will flash it. Should flash it. Amazing. So that's cool. That's done. And then I'm gonna reset it over here, and then I'm gonna go into this this window over here. So this is, I can do a Control 8K just so we kill it, and then we can start from fresh. And this is basically a new boot of the thing. So let's look at what is the issue. Cool. So we have a video command failed somewhere. Failed to write to I2C register. Failed to write to I2C register 103. That's fine. But then we go into we boot Zephyr, and then we see that the device has these capabilities, and then we see that it chooses that format, and that format is not applicable for DCMIPP. It's so weird always saying that. DCMIPP. What does DCMI stand for? Like digital camera interface. Digital camera interface, or whatever. I don't know what the M stands for, but anyway, DCMIPP means it has pipelines, and that's what we're gonna actually sort out today. So anyways, we already are quite familiar with this issue because of all the other because of the Freedom NXP stream. We're quite familiar with this issue. We know what is going on right now, and I dare ask Bartholomew, you can tell what's going wrong, yeah, because of and whoever else came for the Freedom stream, the NXP stream. If you look at this, you already know because of all the debugging we did the other side, yeah. But basically, while we wait for Bartholomew to answer, as I have put him on the spot, what we have here is that the interface, digital camera interface pipeline, pixel pipeline. Anyways, so the interface has a format clash with the camera. As you can see, the camera has the BA81 and PBAA formats available. However, we can see that DCMIPP does not support those formulas. It's not supported. So the first thing, let's actually go find out what formats that DCMI support, and then we can see if we can make these two things agree. Let's see. It might, I think it's a more complex issue than that, but let's see if we can make these things agree. So I'll actually just go back to my notes, which we'll come back to later. So supported formats here. So let's actually just copy that, and jump into some browser into here. Let's jump into a browser here, and I can remove that, and then do that, remove that, and then let's jump into DCMI MPP driver. I expect this is quite a huge driver. Yeah, look at that. This is quite a big driver, actually. Cool. Description of DCMIPP inputs. Let's see. It can do SBGR, SBGGR, SGBRG, SGRBG, SRGGB, and the same down here. So this is like unpacked, unpacked. So basically we can see that we already know what the issue is here because of all of the debugging from the last stream that we did. The issue here is that this camera supports, this interface supports this inputs. However, when we're looking at our logs here, we can see that our camera has capabilities for BA81 and PBAA, and those are not in the supported list. So what we need to find out right now, is whether we can make, whether the camera supports, does the camera actually support this? Does the camera actually support adding more formats to it? So I think I have in my notes as well. I think I have something in my notes as well for this. And this is current IMX formats, and I think this is that. Cool, let's copy that. And then I'll go here, and then we can see if this is actually something we want. So let's look at this. Oh my, these are giant drivers, giant drivers, so huge. These drivers are so insanely huge. No, this is video. No, okay, cool. I see what is happening here. This is BA81, SBGGR8. SBGGR8. That doesn't make sense because that's BA81. There you go. Well, I don't know what happens there. So let's actually look at our log again. But okay, cool. So maybe we look at the pixel format size or something. There should be a thing that tells us what pixel formats are supported. It's not just okay, cool. Let's actually go and find the thing called, size. Where is size coming from? Row bare unpacked size. So we probably want to look at where this is called. I see an 8 there. Do you see an 8 there? Just look at that. So format description 8, row bare packed 10, row bare packed 12, row bare packed 14. So okay, cool. Unpacked 8. That's fine. Row bare packed 8. So they should actually match. They should actually match because this is the 8 one. This is the 8 one because this is here. Look at it. sRGB8. So packed 8 sRGGR8 SBGGR8. Okay, let's go. SBGGR8. Cool. SBGGR8. Robert unpacked. I see. That's why they were recommending that. So this is packed. I know I don't want to touch packed because this is a 10, 12. This isn't the ones we can't do. So unpacked 8. Okay, cool. This makes sense. And anyways, so I spoke to Joshua and Elaine, and they recommended that if I can't manage, is we might need to dump the pipes so that we just pass data through, no processing yet done by hardware. So if we can find a way of just getting the unpacked data and in 8, it should magically fit in there, because I think the pixel pipeline is a thing that's broken. Yeah, that's the thing. We need to add format support. We don't need to add format support, I think, for the IMX219. I expect. Do we need to add format support? Zephyr. That's gonna be something, but it's not gonna be what we want. Let's look into here. And I want to go into pull requests, and in here I want to search for IMX219. Please be on. Cool. Okay, fine. So what we want to know is, oh my god, that depends on so many things. But okay, cool. That's not. Do I really want to know? Yeah, actually makes sense. Driver's image moves the boilerplate in a library. So that one, it doesn't depend on that. It's crossed out, so it's fine. So let's go and look at the files. Let us go and look at the files. Somewhere, some formats are defined. Is it here? No. I think it's here, but it's not going to show us that because that's like a really huge one. So actually, let's go see here. We should find formats somewhere. Yeah, formats here. So video pics format SBGGR8. Yeah. There we go. So that should work. And then there's a 10 full frame as well. 10. But this 8 should technically work with this 8 over here. So what we need to find out is how to dump the pipe. So I see what I was being told to do. So what we want to do is we want to escape. There's an application note over here. That's good. Actually, yeah, let's just use this hour today to discover what the problem is, and then next time we'll build up on that. Bartholomew, is that fine? We just use this hour to discover what is it that we need to change, and then next time we'll actually go and work on the project itself rather than try and do everything and then make a mess. But we always make a mess, so that's not even a question. So I'm gonna come in here and I'm gonna find a DCMIPP for yeah, I think this is the one we want, the application note for this. Yeah. Introduction to digital camera interface pixel pipeline for CMS. Yeah, there you go. DC camera is CM. DCMIPP pixel pipeline. Come on. We've discovered this how many times in this stream? 15 times or whatever. How many pages is 55? That's not too much. What we want to find out is how to bypass the hardware hardware. I know how to do this. We need to find out how to bypass the hardware ISP, and I'll show you what I mean. So the STM32N6, well, the N6 or whatever comes with the DCMIPP. DCMIPP can either, so it can do. Let's go see. This section provides a general overview of the DCMIPP pixel pipeline, peripheral availability across that. It is available. DCMIPP provides communication interfaces with high-resolution camera sensor and a pixel processing pipeline to process the acquired pixels into a usable format by the application. Two acquisition interfaces are available. A parallel interface, which is I think the one we're using, with pins for pixel clock, H-sync and V-sync, as well as a CSI2. No, we're using the CSI2 compliant interface, serial interface, to capture pixels from camera sensors. The pixel pipeline applies processing such as decimation, cropping, downsizing, color conversion, gamma correction directly on the received pixels. So I think what we want to do is we want to find a way of avoiding the pixel pipeline, because I think that is actually the issue, because the pixel pipeline implementation in Zephyr is not complete, according to my discussions with the maintainers of this. It offers a higher performance compared to the former MCUs by moving from AHB slave DCMI to AXI-master. Okay, cool. So this is more FPGA stuff. Increasing data transfer rates from 48 MB to 2002.8 GB. Am I? Yeah. 2.8 GB. Okay, cool. It supports modern CSI2 interface accommodating high-resolution sensors. Additionally, the DCMIPP features a dedicated applicative pipe that spares post-processing and bandwidth by adapting resolution pixel format to the application needs. Typically, it downsizes on the fly. 1080p to that's YUV for 20 for video encoding, and QVGA RGB for NPU analysis. That's quite cool. So basically, the pipeline can compress the video for you so that you can actually use it for something like vision enabled applications at the edge. So basically that's it. The DCMIPP application offers high-speed uncompressed image capture for superior image quality and supports compressed image capture in JPEG format for efficient storage and utilization. DCMIPP offers flexible operating modes to support most camera sensors, supports both color monochrome cameras using various data formats. It is compatible with multiple types of external sensors, including raw Bayer sensors with an internal ISP, sensors supporting video compression, sensors with interlaced video. So that's cool. That's okay. The camera module integrates the following components. Lens. Okay, cool. No, we don't care about what the camera module does unless someone cares. And this is basically image processing right now. So this is how image processing happens. You sample a scene through a lens, and then whatever you sample here is passed in through something called a Bayer filter. And then in the Bayer filter, which is half green, a quarter red, and a quarter blue. This is just how humans perceive colors. This is, manipulated. Image signal processing is happening here, and then we get an image on the other side, basically. That's really what happens. So let's see. What I want to find out is the thing that explains to me how to disable the pixel pipeline, or how to bypass it so that I can dump it. Let's actually just go through the doc. It's fine. There's no need of skipping to something else. The camera module can be interfaced with an MCU using two types of interfaces, parallel and CSI2. That's fine. We know this. So parallel, this is how it works. And then I think there's going to be a... Bartholomew, do you want me to go through this more? Would you like me to go through this? No. Is this something you're interested in knowing so that I can spend more time? I can skip it and go through. I'm trying to find out how to disable the dump. Anyways, you'll ask questions if you want. Anyone will ask questions if they want. Let's look. Yeah. The interconnection, control signals, image data signals, power supply signals, configuration signals, that's fine. And then, yeah, CSI2, same thing. It just goes through MIPP style connection. And MIPP gives you a lane. MIPP gives you something called a lane. And then in the lane, it has like control signals and data signals. So you can see here, control signals down here, and then like data signals up here, and then you can the MIPP thing merges them together. So what does PPI mean here? You need to read this carefully. Yeah, cool, that's fine. Consider this a quick introduction. So this is how MIPP works. I think I showed a thing earlier where anyways, that's fine. We can go back to MIPP another time, but when we're working with FPGAs, we'll jump back to MIPP and we can do a in-depth map into MIPP. But MIPP is this complex standard where they can join control and data signals into one little receiver, and then you can just, you don't need 50 pins or whatever to do it. So that's what that is. Okay, cool. It provides an interface. Yeah, that's okay. Okay, cool. So let's look at this. DCMIPP availabilities and features across STM32. Okay, cool. So that's fine. This is where it's available, and these are the features. Basically, we are on the N6, and there's a pixel clock at 120 megahertz, max in kernel clock at 333 max, a DCMIPP internal clock frequency of 250 megahertz. These are all fast speeds. This is like this. Some microcontrollers don't get this fast. And I wonder what is the top speed of the STM32N6. I don't know. So cool. Yes, dump pipe. Yes. Pipe 0 dump pipe. Pipe 1 main pipe. Yes. Pipe 2, yes. Serial interface, yes. Parallel interface, yes. I see. I feel like this is what we want, but this is already what we have. This is indeed already what we have, because if you go to IMX UVC, yeah, let's just jump around stuff. It's fine. Where's that PR? Where's that PR of IMX219? IMX219 UVC. Yeah, this one. If you go here, you will notice that there is a pixel. There's a pipe 0 somewhere here, and I'll look at it. I'll find it just now. There's a pipe 0 somewhere here. I saw it. I believe I saw pipe 0. Yeah, here. So there's a port 1 and a port 0. Pipes don't really exist in Zephyr, and ports don't really exist in Linux. So, but a port and a pipe is the same thing. A port in Zephyr is a pipe in Linux. Naming situation, but this is just endpoints. It's just an endpoint. It's an endpoint. Yeah. So, port 1. You see, I see what's happening here. But So I wonder why they call this a dump pipe. This. Why do they call pipe 0 a dump pipe? We're gonna find out just now. When we find out why it's a dump pipe, we can actually go and fix something. I bet you this is gonna be 3 days of reading docs and then 20 lines of code changes. Yeah, or at max. It could be 2. It's just finding out what we need to touch. That's which is really the biggest problem in embedded. You have to read so many manuals before you can find out what we need to touch, even though it's just one line of code that you need to change and then everything works out. So, cool. Welcome to Real Embedded Development. Hi, Hostel Life. How are you? I'm gonna take it. Does anyone have any questions so far before I keep going? I'm just shouting at Bartholomew at this point. We found it. We found it. Check this. We found it. Bartholomew, tell me if I'm wrong. So pipe 1 and pipe 2, they come out of the ISP. Well, this doesn't look like it's going through the ISP. So pipe 2 doesn't seem it's going through the ISP. So this is post-processing. But they're kind of joined here, so I don't know about it. But look, pipe 0 just goes whoop straight. Do you see that? Pipe 0 just goes straight. So this is a dump. This is that makes sense. Okay, cool. So this is starting to make sense. But I still don't understand ports in ports and how to use them. But by the end of this, we're gonna understand. We're gonna know. I think so. So we need to find a way of using pipe 0. And I can see here. Look, I can see here. Look here. I can see here. Capture point is using endpoint at 1. I need to understand how Zephyr ports work, because this is the change is gonna be here. It's probably something like endpoint at 0 here, because this is, look, this says where the endpoints defined. That's what we want to know. Yeah. Look here. So this says, oh wait, is this in some sort of DTSI? Yeah, it is in a DTSI. Yeah, okay, cool. So I do believe that endpoint 1, endpoint 2, and this is pipe 0. I do believe that if we can find a way of changing this into endpoint 0, this thing might actually just work. But we need to know how to change this to endpoint 0. We can't just, well, we can, we just don't know if that's what we need to do. But let's actually just open this file and look at it. Yeah. I'm gonna look at your comment just now, Hostel Life, if you want, if you allow me. I don't want it to do that. I want to still have this. So I want to come here and do this until yeah. I want to open that on the side, and then I'm gonna go read some comments. I saw some comments come up. Hostel Life says, I'm a med student. I got bored learning circuit computing in actual and got hooked to your videos and learning something through your videos. What could a layman or a beginner expect from your live videos? You can expect to understand what to go and learn. You can also expect to understand what questions to ask. And if you keep asking questions, I'm probably going to be able to answer them. So whenever you feel confused or something, just ask the question and I should be able to give you some sort of answer, which should guide you. Yeah, welcome. Learn something. It's always good to learn some stuff. Okay, cool. So this was, where do we want to go here? Yeah. So let this stay. Let this stay as it is. So let's come here and actually no. It's fine. I know what to do. I just need to go to that DTSI and look at it. And I need to find out what endpoints are. The common one, not that, not this. Yeah, I need to come here and say view file, and I need here. Yeah, I don't want to do it. I really don't care. I don't wanna open a PR. That's just the link I'm used to. Okay. Can you show me this file? Yes. Amazing. So first of all, let's find endpoint. That's all. CSI interface, DTSI. Let me see. Does this import anything? DT binding, RPI connector, pin control, DTSI, and this DTSI over here. So perhaps let's go and find them. Shall we go find these? I think it's going to be open a new one here, and hopefully it's on the branch that we want, and then we want to go into DTS. I want to go into DTS. And we want to go into ARM, and we want to go into no, this is the wrong place. I want to go into DTS, ARM. Is it ARM? Yeah, I want to go into ARM, and I want to go into ST, and then I want to go find N6, and then I want to open which one. So I want to open N650 DTSI, this one, N6570X0, this one. I'll come back for the pin control one. Ooh, we're coming close to AXI. Once we're coming close to AXI, then we're actually good. Do you import anything? And 7 DTSI, cool. So we have AXI here, and it's being there. Okay, cool. So which one? N567 DTSI. I think that one also imports the N6. Cool. N6. That's fine. Those are bindings. Okay, cool. I think I have an idea of where this is going. But let's see. Oh, we found them. Port 0, endpoint, remote endpoint, that's it. Port 1, pipe dump, endpoint at 0. Pipe main, endpoint at 1. Pipe aux, endpoint at 2. Bartholomew, do you see the thing? Do you see what we need to change? This whole video is a challenge to Bartholomew to be one step ahead of me. And if you don't know, Bartholomew is like, I'm Robin, he's Batman. Do you see what to change here? I'm not going to change it until you tell me whether you see what to change, Bartholomew. We're waiting. Bartholomew has to give us a change. We're waiting. Poor dude. Poor Polish dude. It just goes online, and then there's this dude to just make... Sorry, bro. I don't mean to bully you. Basically, what happens is we just found the 3 pipes. This here, this corresponds to this. Ah, come on, Bartholomew. This is not so hard. Anyway, um, okay, cool. So the dude, he likes this. Okay, cool. So check. We found it. We found it. Look, this is the dump pipe. This is the main pipe. This is the auxiliary pipe. So, and those pipes are here. So this is pipe 0. And this is the ISP pipe, which is pipe 1, and then this is an auxiliary pipe, and they're all described here. So pipe 0, dump pipe; pipe 1, main pipe; pipe 2, ancillary. So basically, it's a one-line change. It's a one-line change. It's a one-line change, and it's a one-line change, and it might work. It might just go work. I'm hopeful, but you know. So if we try to, if we basically, and I don't want to go and look at that driver. I don't want to go look at that driver. I'm so scared. I probably have to at this point. So what we want to do is want to point to this endpoint 0. That's it. I think we're pointing to endpoint 1. So let's go actually look at our application. Bartholomew, you know everything. Don't worry about it. You know everything. I promise you, you know this stuff. It's just maybe it's not connecting right now, and I'm sorry to put you on the spot. You know everything. Remember we were looking at this. So look here. So we have this DTSI here. This DTSI, and it's the capture port, which is what our app.main, our app. Look here. App.overlay. Look at the app of our app.overlay is using the CSI capture port. Okay, cool. And I think down here we somewhere we enable the CSI capture port or something. CSI interface, CSI dot, CSI AP in. That's fine. This is okay. We'll modify that just now. So yeah, we'll modify that somewhere. Just now. We'll actually modify this port so that it points at this. So this is using endpoint 1. Endpoint 1, as we've just discovered, is actually DCMIPP, but it's a pipe main. Okay, pipe main goes through the internal ISP. DCMIPP, DCMI pixel pipeline, has an internal image signal processor. And we just don't want to use that right now because we don't want to go and debug it. We don't know if it works, if it doesn't work. No one has tested it. So cool. So what we want to do is jump straight from the IP plug, which is FPGA speak for this is a system that does the video, and we just want to dump straight to from the camera port straight to the receiving port. We don't want to use the ISP, basically. We want to bypass the ISP. Right now, our code is actually, we can actually find it. Let me go and look. So here we have that. So let me go here and find it. This is where we built. Yeah. So we can do cut build. Provide a link to this. Perfect. So Bartholomew is confused and I need to do that. So DCMI PP application note. Okay, cool. So application note 6211 on this link. I will leave it in the chat, but you can also pause and see this link. Application note 6211 ST. If you search this, you should find it. Is this? Is this the document that you're looking for, Bartholomew? I hope so. I hope so. This is the document you want. So what I want to do is cut build Zephyr Zephyr.dts, and then in here what I want to do is grep CSI interface, and then after that I want to do an A10 so that we see. Yeah. Let's do an A20. Okay. A30. Sorry, I didn't mean to make it hard. I just, sometimes I assume everyone has everything I have. A30. So look, CSI endpoint, port 0, port at 0, CSI endpoint, blah, 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 EP out. That's fine. I need to go 40. So port 1, I need to go 45 or something. Yeah, you see, so this is endpoint 0, endpoint 1, and all of that. But what I need to find, actually, it's not CSI interface. What I actually want to find is, sorry. What I want to find is this thing. What I want to find is, not that. What I want to find is this. What I want to find is the CSI capture port, actually. And I'll do an A10 after that. A5 even. That should be fine. CSI capture port. Capture port. Okay. So CSI capture port. It is in DCMIPP. This is in aliases. That's fine. This is okay. This is coming from DCMIPP. Let's do an A5 and a B5. So there's that, and then where are you? It's in ports, port at 0, endpoint 1. So basically this is what we need to interface. Or if we want, we can just modify this, the CSI interface. Okay? We can just modify that. We can just modify that and point port at 1, CSI capture point, to endpoint at 0. I think we can do that. I think we can actually do that from our overlay. Let's actually try that. What I want to, the next time I search this, what I want to find is CSI capture port should be at endpoint 0. The next time I search for this, basically, is what I want. Let's do CSI interface. Okay, so here goes. Interface. Okay, cool. So let's actually modify this and see what happens. Whoa, this is becoming such a... It's becoming so possible to do this. I didn't hope to actually be able to do this. I thought I would not be able to do this, but it seems like we can figure stuff out. I don't even understand how I'm doing this. So and then port at 1. Yeah, we want to modify that one. And then we want to do CSI capture port. Capture port. Endpoint at 0. And I'm so impressed that I could find out where these things are defined, because now I actually know where ports come from, because they magically appeared for me before. They just magically appeared, and that's because I wasn't going all the way to the DTSIs and everything, and that's pretty cool, pretty cool if you ask me. Pretty cool if you ask me. Yeah. So let's actually do that. Let's CSI interface port at 0. So let's actually try and build it with this. and see what error we get. Remember, the error that we're getting right now is this. Like I said, this is going to be one of those things where we read 50 documents and then we change one line of code and maybe it works, or maybe it's a bigger problem and we have to go change a lot more lines of code. So let's actually build, and then I'll open up the floor to as many questions as I can while it's building. So let's actually build. Let's build it. And hopefully this build works. Questions now, please. I could just go to the place where this is actually defined and change it there. I could, because now I'm changing something that I didn't. Let's go change it at the source. Okay, so now I need to find which file is this, which not even this one, not even this one. I need to find this one. What file is this? I need to find this one. Find this one. So this is Nucleo common DCSI. Nucleo N6570X0. No, this is wrong. 57X0 underscore Q underscore common DTSI. So here it is. Here's the file that we're looking for. And what we want to find is the guy or the thing called capture port. CSI capture port. Yeah, here, capture port. So here, let's actually just change that. We can change it here. Later on, we'll learn how to change it straight from the overlay, which I don't know how I messed that up. I probably have to actually modify the and CSI capture port itself, or and port 1, but we'll get that. That's a different Zephyr issue that I have to figure out. For now, we're just debugging and we want to make it work. So let's actually try and build with this first of all and see what happens. Yeah, let's build. Any questions? Any questions so far? I don't have that much time left because I have a meeting at work in do I not? Tell me if the meeting is off. If the meeting is off, then maybe. No, I have a meeting at 4:30. I'm pretty sure I have a meeting at 4:30. So cool. Anyways, which is 30 minutes from now. So I'm gonna push us into maybe 15 minutes and see where we go. But this actually might actually change something if this does build. If this doesn't build, then we have to figure out a lot more stuff. It's basically going back to the other thing, and we'll see. Any questions so far? Any questions so far? I thought I had a meeting at 4:30. I should have a meeting at 4:30, but if I don't, yeah, and I still have to go watch my live stream for work and everything else. So that's a different story. It's so scary. It's like getting close to building. I can't handle this. I can't handle this. It's getting so close to building, so I don't know where. You're joking. No way we can figure that out. No way it works. No way. No actual way. Put it in bootloader mode. No way. It's just gonna crash. It's just gonna crash. There's no way that works. No way it's that easy. It's flashed. I'm gonna replace the thing. I'm gonna replace the thing and then no way it works. Do you see what I'm seeing? It's changed. It's not changed. What is PRAA? What is PRAA? I have no idea. It's a different thing. It's kind of fixed, but it's not fixed. Because previously it was DCMIPP, pixel format PRAA is not supported. Fine, fair, cool. And then camera capabilities, BA81, PBAA, and then now this is the new one. DCMIPP, dump pipe output. It knows we're using the dump pipe. Format PRAA, incompatible with source format PRAA. Let me ask Joshua quickly. Am I reading this wrong? Bartholomew, can you read this? Can you read this? Am I looking? Usually sometimes I miss some letters. Bartholomew, can you read this? Is it saying that the pixel format is the same on both sides and it's saying it's incompatible because it's PRAA is incompatible to PRAA? Do you see that? What is PRAA in the first place? What is PRAA? I'll put it in the comments so Bartholomew can look at it while I jump into something else, because he needs to. If Bartholomew needs to read this and see if I'm reading it wrong. Yeah, it looks the same. The one thing I can't see is the camera capabilities don't match with there's no PRAA in the camera capabilities, so I don't. Does it want PRAA? Oh, whoa. I don't know. Anyways, it's getting so close to I have to go work. I actually have to go do my day job. This is kind of my day job, but this is like not the, it's not my day. It's like not, it's, I have spent enough time in this today. I'm just confused. First of all, let's actually go find out what PRA is. That's number one. Let's go find out what PRA is, and then we can just go about and find all these other things. Is it here? And this is in video. So we need to find PRA, PBAA, PGAA, PGAA, PRA. This is PRA here. But it looks like it's PRAA small. Okay, PRAA. So PRAA is format sRGB10P. There it is. And I'll give a link to this because I know Bartholomew will want to touch this later. So it shouldn't do that. It shouldn't do that. Unless the IMX219 does actually support this and we can coerce it into giving us that. Let's actually go and look at the document for the IMX219 and we can see how many. So this is the data sheet. That's a really bad thing. So that's can we look for formats in here? How long is this document? 96. That's not big. Format. Let's actually. Oh crap. Hopefully we find something. Format. Output data format. Yeah, that's kind of what I'm looking for. Output data format. CSI2. Let's actually see. So what's happening here? Can you tell me which formats you can give me? Can you please tell me? CSI2. It's either effective pixel row 8, row 10. It should still work because that's a row 10. This is a row 10, isn't it? This is a row 10. It should still work. This is a row 10. PRAA10. So row 10. This should be a row 10. Yeah, this is a row 10. PRAA, it's a row 10. So first of all, okay, cool. So let's actually go online and look for it. Row 10 pixel format. Let's go online and see what row 10 pixel format means. Row 10 pixel format. What did I Google? Yeah, that's wrong. Why are you putting a space there? Differences in pixel. Okay, cool. I saw it just now. Is it? Can I find a row 10 here? 10. Okay, cool. So no, I don't want that. So this looks like row differences in pixel parking and unparking. That's cool. This is kind of what we want to learn. I don't want to be on end video. It's bad. Bad for me. BG10. I need to find out about row 10 pixel formats. Okay, cool. This is sort of a good thing. We've sort of debugged to a point where we know what is broken, and we can sort of next time we can start from here. So this is actually good because, anyways, I can also do this. I can also do this. This is also another way of finding out about this. So we know PRAA10 is, what is this? PRAA. Oh yeah, we can just get PRAA pixel format and it can tell us about it. PRAA pixel. I'm running out of time. I have to go back and do other things at my day job, so I'm going to stop there. And what I'm going to do is I'm going to go to the Zephyr community, and I'm gonna start a discussion on this so that I can learn about using this pixel format, and then we can figure out how to go forward from here. Yeah, we can figure out how to go forward from here, and then I'll basically spend the rest of this week fixing this bug. I think we're so close to like just nailing it and pointing at it and going like that's the problem and fixing that, but we just need to furnish our information database with a bit more information so that we can actually fix it. So what I'm going to do is I'm going to stop here today, and I'm going to go compile a situation report of what is happening, and I'm going to compile a situation report of what is happening, and then the next time we stream again, this is going to be it. So I saw something here. I saw some sort of the same fail. I saw some sort of the same fail over here, because I saw something like, look here, to select alternate formats, you'll need to combine sRGB, which is pixel format equals PRAA. So what we need to do, it looks like, if this is the solution here, okay, PR. So this is, first of all, sorry, this is quite shitty of me. Okay, now you can actually see what I see, PRAA. Okay, Bayer formats cannot be rendered by EGL or DRM, and you've got no AGC, all white balance, and all of that stuff. The whole point of Live Camera is that it introduces all. By the way, we're trying to build Live Camera for Zephyr. Somehow we'll figure it out. But if you want to set up the links manually, then you can do so with Media CTL and before L2 CTL, and it'll be something like to V4 CTL and then point to PRAA to set up the CSI receiver to the default format for the IMX219. This doesn't make sense. The IMX219 produces PRAA. We chose PRAA from the pixel pipe. So something else somewhere has to be modified so that this PRAA can work with PRAA, because it's here. So dump pipe output PRAA incompatible with source format PRAA. Let's go find this. No, I'm not gonna go find this error. I've already said I'm stopping. I'm gonna stop there. I have to go to work, and tomorrow we'll go on with this. This whole week is going to be dedicated to this, and we'll figure out a way of making this work. I think we're very close to this. I think we're going to make this work. So thank you all so much for showing up today. Once again, my name is Zach. This is my stream. We usually find bugs and we learn how to fix them, and we fix them slowly in a real world kind of way. And sometimes we find real bugs in the real world, and we do fix them, and this is part of the process every day. So thank you all so much for showing up today, and cheers, and see you next time. Thank you so much. See you. And in the description of the video, there's a link to our Discord community. Join us, and let's see what we can learn. Cheers. Bye.